All right, guys. So in this platform, I need us to consider this typical exam question as a request that we had. So we are going to work out our KZN province that is for our grade 10 mathematics as a common test that we had in this September. So if you're to consider this part, it was supposed to be 1 hour 30 minutes, 75 marks. So we're going to see with the information, as I said before, read instructions. Make sure that you read the instructions that you are given. So they were given the instructions and information, which is of best that you are supposed to answer all the questions. Okay. That is given number the answers correctly according to the numbering system used in this question paper. And also you're supposed to clearly show all calculations, diagrams, the graphs, etc., whatever that you're given, which you must have in your presentation. Try by all means to present properly, clearly, okay, which you have used in determining your answers. So make sure that part is to be considered. Also go through all these instructions, guys. Whatever that you're given, answers only will not necessarily be awarded full marks. So you need to show calculations there. So they are saying answers only will not necessarily be awarded full marks. You must be careful there. Okay? You may use an approved scientific calculator, non-programmable, and non-graphical, unless stated otherwise. So as long the calculator that you're using is approved, okay, that is fine. And round off correct to 2 decimal places. Remember, guys, your answers, there's instruction. Unless stated otherwise, they can give you another instruction. Okay, we had these instructions before, so make sure that you go through each and every instruction that you are given. So without wasting time, let us quickly rush through our questions and see what we're given. On question number 1, financial mathematics, as we just had our financial mathematics from introductions. I just hope those introductions, they helped you guys, for those who have been watching our videos. Question number 1. An advertisement in a local newspaper reads as follows. It's an advertisement. Buy an iPhone 14 Pro Max cell phone for only 1,029 Rand per month. Per month. Per month, each and every month. You have 36 months to pay. Take note, you have got 36. They told you that. No deposit is required. Then you say, okay, it's a cheap iPhone, because they're saying no deposit is required this time. So the question was, on 1.1, calculate the total amount to be paid over a period of 36 months, which is this period that you are given here. You have 36 months to pay. So in those 36 months, what are you going to pay? That was the question. So it is simply the amount, the total amount. The total amount. So you can just write A, or you can write total amount. Okay, guys, it's a simple instruction that is here. You are told that you're supposed to pay 1,029 Rand per month. Per means per one, like 1 month, each month. You have to pay 1,029 each month. Each month. That is what it means. Each and every month. Each and every month. And how many months are you supposed to pay? 36 months to pay. Paying this each month. So how are you going to get the amount? You simply have to multiply to say this amount. You're supposed to add them like this. 1,029 plus 1,029 plus 1,000 and so on and so on. 36 times adding those. You're supposed to do like that. But guys, you can avoid doing that by simply multiplying that amount of 1,029 to the number of times that you're going to pay it. How many months? Because you're paying it each and every month. But how many months? 36 months. Each month. 1,029. So that was your question there. You have the total amount. So that was going to give us a total amount of 37,044. Now you can see, okay, over this period of 36 months, this is what I'm going to pay. This is what I'm going to pay at the all amount, all the money that was being paid, all the money that was being paid monthly is going to accumulate to this. It is going to be this at the end. This is your total amount that you're paying. So before you buy, you have to check what is it that you're going to have at the end. That is what they are also trying to have you guys in mind. You must understand that. All right, let's move on. 1.2. The monthly installment quoted in the advertisement is calculated on a hire purchase agreement. Okay. Guys, you must be careful. Very, very careful. This is exam. And exam, you know, they want to test you. So don't allow them to play around with you guys that much, okay? Just try to understand the concept. This is what they're saying here. They're saying the monthly installment quoted in the advertisement. Which monthly installment? This one. This is the one that was quoted. Isn't it? It was the one that was quoted. They're saying this monthly installment that we are seeing there is calculated on a hire purchase agreement. Take note, on a hire purchase. The moment you're dealing with hire purchase, what is that you think about? You're dealing with hire purchase, you think of what? You think of the simple interest. Remember your introduction, simple interest. I mentioned also hire purchase there. Which agrees or which charges interest of. So you know that per. Now take note, per annum. All right. So guys, we want to be very, very careful here. We need to be very, very careful. What is it that we need? It is being taken per annum, meaning to say each and every year. So you're talking about a yearly, per annum, yearly. That is what? Yearly. Not now per month. We're talking about the monthly installment. So what is it that gave us at the end of everything? This is the money that we got at the end of 36 months. So we are going to take that and consider it to be our amount. Because remember, we're talking of the simple interest, like I said, hire purchase. Think of what? Simple interest. So on simple interest, you're going to need the amount. Remember, amount is equal to P into 1 plus IN. The amount is that amount that we're having there, the one that is accumulated to over the period of 36 months. That was 37,044. Given an interest that we have here of 8.2% per annum, meaning to say yearly. divide this one by 100. Remember, we have to divide by 100. It was going to give you 0.082 as a decimal. So, as we have to consider, we've got n, the number of years. The principal is the money that we need to calculate, because they are saying calculate the cash price of the cell phone, because this amount that we are seeing, it is being obtained from a higher purchase. So what is the initial amount that was supposed to be of the cell phone before the interest was paid? Remember, when you're dealing with higher purchase, they put a what? An interest there. So they're saying before that, what was the principal, the money that was supposed to be used to buy this iPhone? Because this amount that we are seeing, it is carrying an interest in it. So this is the question. What was it? That is the cash price. So you need the period, the number of years, and within this period that you had this amount. What was the period? Remember, you're using what? 36 months. These are months. But n is the number of years. So how do you obtain the years? 36 divided by 12. Each and every year, we've got 12 months. So if you do divide this, you're going to obtain what? A 3. Meaning to say we're talking of what? 3 years. We have the number of years there. So that was the concept of this question. You see how they try to hide this information that is supposed to be direct, because it's exam, supposed to be like that. So you must study, understand concept. So we can calculate our principal. Like I said, this is higher purchase. You deal with what? Simple interest. That's simple interest. So we know that amount is equal to what? P into 1 plus IN, or simple interest. And you want to calculate the value of P. So you can simply remove this bracket here by dividing by it both sides. 1 plus IN, because you're multiplying, so you can divide by that bracket. 1 plus IN this side. So by dividing by these guys, as you can see, you are getting rid of this, remaining with what? With P. So P is equal to this, which is A over what? 1 plus IN. You can put the bracket, you can choose not to put the bracket. You can choose not to. So the amount is there. What is your amount? 37,044. You substitute your values, everything over what? 1 plus the interest rate as a decimal per annum, 0.082 times n, the number of years. How many years are you having? So that was going to give us what? The principal. That is the cash price of the cell phone. Just like that. So simplifying this on your calculator, guys, you're going to obtain, make sure that this is, you are dealing with money, round off to 2 decimal places. Your answers. So if you have a challenge with that, make sure you fix your calculator for that calculation. For that particular calculation. Remember, you're told 2 decimal places, but here it's not about being told. You're dealing with what? With money. So you round off to 2 decimal places according to our syllabus. So this is it. Let's change this. This one, shift, go to setup. You can fix your calculator there. Number 6, then to 2 decimal places, as you can give, you are given 0 to 9. These are decimal places after the comma. So we need 2, you press 2. So whatever that you're going to simplify is going to be given to 2 decimal places. All right. So you can fix that. So let's put our fraction. So we've got 37,044 over what? This is 1 plus, you can multiply this 0.082 times 3. All right, you can even put a bracket. This one, close it, put a bracket here. Between these 2 that are multiplying, just put them in just the same way that we have there. You can present it that way. So this is it. As you can see, your answers are being given what? Direct to 2 decimal places. So you can just fix your calculator. So this is what you're going to have at the end. This is the idea there. So you're having 29,000, as we had there, it was 29,730,34. So we're talking about what? The cash price. The one that we had. The cash price of what? Cell phone. This was supposed to be our cash price. Okay, so revise your finance, guys, because they do ask these questions now and again, repeatedly. So if you revise a lot of question papers, it's going to help. 1.3. The cost of the cell phone is subjected to inflation. What is the cost of the cell phone? The cash price. Isn't it? The one that we are given, the cost, the cash price. So they're saying, because this is where we do not have any interest. Remember, principal is the starting amount. This is the amount that you start. You're saying the cell phone is supposed to be sold at this price. But what we calculated on 1.1, it was the amount which was carrying an interest, as we are told here that it was calculated on hire purchase agreement with charge, which charges interest of. Yes, here we're not calculating interest, but it was carrying the interest as we are calculating it. So this is not the amount, this is not the money that we are talking about for now. So let's just remove this part. We're talking about original price, the cash price of the cell phone. The cash price. They're saying the cost of the cell phone is subjected to inflation and increases to a cash price of after 3 years. When we are talking about this, not to say someone is buying this under a higher purchase or what. No. Forget about, guys. Forget about here what happened about the higher purchase, this and that. They are saying this cost price, this one, the cost of the cell phone, which is the cash price, we take it to be our principal. I want you to understand this. That's a 1.3. So you're going to take it like this. You are given the principal amount. They are saying take that one because that is the cost of the cell phone. Price of the cell phone. The cost price. This cell phone, this one, is subjected to inflation. That is what we are saying. We are given. It is subjected to inflation. When it is subjected to this inflation, what is it that is going to affect here as we are given? What is it? Is it that is affected? Yes. All right. Okay. We see this thing of rushing, guys. I'm now having double this, double that. Okay, no problem. So we are saying, if it is inflation that is subjected to, we do know that the amount will increase. But inflation falls under what? As we talked on our introductions, inflation falls under compound interest. It's no longer about simple interest, this one. Falls under compound interest. So we are given the amount after 3 years, number of years we are given. Calculate the annual inflation rate under what? The compound interest. We're talking of inflation. Higher purchase, simple interest. You see now. So this is now our amount. This is now the number of years we are given. So the amount you have it there after those number of years. So the amount is going to be what? 31,000 968,11. And we are given 3 years. Guys, answer the question. Answer the question. And they want you to calculate the what? The rate of inflation. At which rate under compound interest? At which rate? Remember your compound interest formula. The amount is equal to what? That is equal to P into 1 plus I to the exponent of n. So what you can do, you can make this I to be the subject, or you can substitute your values. Just for the sake of us all understanding, let's just substitute our values as they are. So this is 31,968,11 for the amount is equal to the principal. You have it, 29,730,34. This is equal to into 1 plus, you need to calculate I there, and you do not know it. But n is the exponent, which is 3. You can write that, substitute the values there. You can calculate the value of I there. We are now playing with our mathematical skills there. What can we do? It's a product there. So simply divide 29,730.34. You do the same thing this side. 29,730.34. Take note, we've got our equal sign there. Okay? So these two can cancel. As they do cancel, take note, you are remaining with what here? You are remaining with 1 plus I raised to the exponent of 3. This is cancelled. So what were you going to do with exponent of 3? Remember, exponents. How do you remove this exponent? The opposite. You introduce that with the root, but with this number which is and the exponent inside of the root. That is to remove this cube root. So meaning to say this side, we're also going to have what? The cube root. In order for you to neutralize this, to remove that cube root. So you're remaining with 1 plus I in this case, which is equal to this. The cube root of what? 31,968,11, everything over 29,730,34. This is what you're going to have. As we have this, we can now calculate our I. What is affecting? It is this 1. So we can transpose the 1 to the other side. It becomes a negative there. So meaning to say, we have the cube root of this. I'm just going to rewrite, guys. Do not worry. 6, 8, like this, comma 1, 1, everything over what? Everything over this, 29,730,34. Then as I said, we're going to take the 1 to the other side of the equation. It becomes a minus 1. It was a plus, now a minus. This was supposed to give us, this part was supposed to give us the value of I. But as we do understand, the I that we are going to obtain as we had on this formula, it was a decimal. But this is supposed to be the percentage. As we do understand, whatever that you're going to have here, it is going to be a decimal. So to avoid everything here, whatever that you're going to obtain on your calculator, you're supposed to multiply it by what? By 100%. The moment you multiply it by 100%, it means you're obtaining I as a percentage. As you are given here, as you are given these questions, here the charges interest is 8.2% per annum. So they want you to have it the same way as a percentage. So you know that when you were removing the percentage, you were dividing by 100. Now it is the opposite. So this is what I'm trying to say, guys. On our calculator like this, we just put that and multiply by 100. So there, just open a bracket. All right, insert these values first, the cube root. So as you can see, the cube root is there, this one, the cube root. So it's going to be shift there. It gives you the cube root. Shift, then you press the square root. Then let's have a fraction. 31968,11. Okay, let's divide this to 29,730,34. Whatever that you have there, move this, and you're supposed to subtract one. One is not inside the square root, so you're supposed to move outside of the square root, okay? Here, until it is outside of the square root, then you can subtract a 1. You're supposed to see the 1 not moving with the square root, not like this. I want you to see what's going to happen if you do it like this. Minus, you see, the square root is also moving with you. It is not supposed to be like that. The minus is not under the square root. So you move aside like this, then minus 1. Close the bracket. So this is the decimal that I'm talking about to say, if you're going to use it like this, you're going to get a decimal, whatever that you're going to have. Remember, here it's only that we fixed our calculator, so it shows us only 2 digits. There are so many digits there. It only shows you 2 digits. So you're not going to do like that. You're simply going to multiply everything by 100% because you know the answer is supposed to be a percentage. So by multiplying by 100%, answer was going to be what? 2,45. So this is what we have. That's why I'm saying use your calculator at once, because if you use the first stage, you get, because the calculator is limiting if you have fixed it, unless if you are using it in the normal mode. Okay, let's do this. Let's go back to the normal mode. Press 8 and press 2. In the normal mode, as you can see, it gives us, like, let's remove this 100 here. It gives us all the values, like 0, so you can even write this value. But you saw that when it was fixed, it was just showing the first, this one, 0,02, because we fixed it. But if you want it like this, you can even see, okay, these are the values. What? Then you can even multiply by 100. You're not surprised even if you see, sorry, it was supposed to be by 100. So let me just multiply by 10 again. So if you see this value is 2,4, like what we had there, which was 2,45, you're not going to be surprised because you have those values. So guys, the use of your calculator is in your hands. So at the end, our answer to 2 decimal places is going to be what? 2,45%. It's a percentage, this one, which is being taken yearly. As I said, yearly, it's what? Per annum. Per annum, yearly, each and every year. Per annum. So you must be careful. Very careful, the presentations and so forth. So I think for this finance, we had a lot of time as a revision, also to understand, because now we are doing revisions, guys. This is no longer about answering the topic. It's about you guys understanding, because at the end of the day, they are not going to ask you the same question. They ask a question with relative information that you have. So understand information. Question 2, 2.1. On a trip to America, Cherit booked into a hotel for 5 days. Okay. For how many days? 5 days. The exchange rate is, the exchange rate at that time was $1 as to what? 18.73 rate. Each dollar that you have, it is equivalent to 18, what? That is 18.73 rand. The cost of the hotel per day is the cost per day, per day. I talked about this issue of per. If you still remember here, when we're dealing with per month, each and every, so each and every day per day, each and every day is supposed to pay $104. How much did she spend in rands for 5 days? For these 5 days here that are indicated here. So you can say, okay, in terms of the dollars for 5 days, in terms of what? In terms of the dollars for 5 days, what was the total cost? What was the total cost for 5 days? In terms of the dollars, as we can see here, because it's being charged per day in dollars, per day in dollars. Each day is supposed to pay $104. each, like I said, for how many days? For 5 days. For 5 days. So we're going to multiply this by 5. So this total cost that we are seeing is in dollars. So it was going to give us $520. This is the total in what? Dollars. But they are not asking this in dollars. No, they are saying this in rands. So that is where we go back to the conversion table now to say, all right, $1 is equal to what? So what about $520? It is equivalent to what? In South African rands, we do not know. So you can just call it X. And that X is more. So you can just find X by the cross multiplication, if you understand that, guys. The way that you solve here, I said there are so many ways. You can have it as a fraction. This over this is equal to this over this. Or you can just cross multiply easily like that. This one, it multiplies this side. This one, it multiplies this side. When it is a more. So if you multiply 1 times X, you've got X, which is equal to, you multiply these two. So it's 520 times 18,73 South African rands. So the amount, the X there, is the one that we need, which is the product of the two. And that was going to give us 9,739.60. So this is the total in what? In South African rands. That is supposed to be paid. But in the dollars, it was supposed to be what? $520. So they want you to know this because one day might have a visit to or you might have a trip to America and they are charging in dollars. And you need to convert your money from South African rand to dollars. So understand the concept. Or you could have converted this first to rands. Then you multiply by 5. You convert this to rands first. Then you multiply by 5. So I want you to do that. Okay? I want you to do that first. $1 is equal to what? 18,73. What about $104? So this is another way that I want you to finish this and find the answer. So I want you to get the value of X. Then the X that you're going to get means you're going to multiply 1 and X, which is X is equal to 104 times 18,73. Okay, let's just do it together. 104 times 18,73 is going to give us 1947,92. Okay, we are converting to rands. This is the total. This is not the total like for what he is paying for 5 days, but the total per day that we converted to South African rands. But we are being told that he spent how many days? 5 days, because this amount that we are seeing here, this one, it's per day because it's being taken from $104, which was being paid per day. So we just converted it to rands. So as we converted to rands, it means it is still per what? It is still per day. So for 5 days, what is it going to be the amount? So for 5 days now, what are we going to do? We take the amount that is being paid per day, whatever that we have there per day, we multiply it to the number of days which are being given by what? By 5. So by multiplying this by 5, we are going to have the total amount, which is going to be 9,739.6. But this is money, so you're going to just put a 0 there, 60. 2 decimal places. You have the same answer as we had it from that. So you choose, guys. It's up to you the way that you're going to calculate this. Question 2.2. So we are given Mr. Zungu from Sparks Estate Secondary takes out a loan, take note, buy furniture of his office. Took a loan. So the loan is repaid in one payment of in one payment of, meaning to say, when it has accumulated everything, this is what is supposed to be repaid. So we're simply given total accumulated amount of 139,389.80. So this is comma there, 80. At the end of 4 years, we are also given the period, the time frame. The interest paid on the loan is, we're now given interest of 10%. So if you divide that by 100, remember, as a decimal, it was going to give us 0.1 per annum, which is true, but being compounded annually, compounded yearly. Remember the issue of compounding, compound interest. There we are it is being compounded annually. I say this on our introduction, that it is when it is annually or when given yearly like this, there is no effect on anything. The number of years, interest is not affected. It's not affected because we're talking about yearly, where the interest was supposed to be divided by 1, so there's no effect. The number of years we're supposed to multiply by 1, so there's no effect. It is only an effect when it is maybe compounded quarterly or monthly. Those ones, not compounded annually, guys, or yearly, because it is taken from that same per annum. So nothing is affected. Calculate amount of money borrowed from the bank to buy furniture. The money that was being borrowed is the principal amount. You refer that as the principal amount. So what is the value of P, the money that was being borrowed? As we consider that this is a compound interest. So from our compound interest formula, remember this time amount is equal to what? P into 1 plus I to the exponent of n. So you need this P. So you can simply divide by the bracket. Remember, guys, what I said? Simply divide by what? The bracket as it is. The bracket as it is. Talked about this on our introduction. So this can cancel. And you are remaining with what there? P, which is the one that you need, your principal. So the principal is equal to this formula now, which is the amount. To substitute, what is the amount? 189,000, whatever that you have there. You substitute your values. Everything over what? 1 plus the interest rate, which is 0.1. The number of years being 4. So that's 0.1 raised to the nth power, which is what? 4, the number of years. So that's our P. Just like that. So there you can simply use your calculator as we had previously. So you can have your calculator, that's have a fraction, insert your values. So that's 1,893,89.8. The 0, there's no effect there, guys. Okay, then open a bracket in the denominator. 1 plus 0.1. Okay, close this, raised to the exponent. So press this x to the exponent of, then you put a 4 there. So this is what you're going to have. As I said, you can even fix your calculator. So you're going to go back 6, then fix number 2 to 2 decimal places. So it was going to give us 129,355.78 as the principal amount, the money that was being taken as the one that was being borrowed. This is the one. Borrowed 129,000, 355.78. The principal amount. So this is what we have there. So this is the amount that was borrowed from the bank. So do revise your finance, guys. We've been talking about this. Also on question number 3, there's another question that we actually discussed, this type of a question. And some of you guys were saying, not understanding. But you see, this is the exactly discussed, like a question similar to this. And it came the same way. So I want us to understand this. For another time, another explanation. Let's see if it's going to work. You are given there on 3.1, given the probability of A, 0,4, probability of B, probability of A and B, meaning so you're talking about what is on the intersection A and B. Determine 3.11, probability not B. If, guys, the presentations were being made, if we're talking about presentations being made, whether the sets were joining, because there's and, so we know that it's going to join. This is your A and B. If we are talking about something that is in B, let's say something that is in B, let's avoid this, not B. We want something that is in B. I'm not saying B only, no. B only is something else. This is B only, this one. When you're talking about B only, we're talking about this part where A is not there. But I'm saying if we're talking about what is in B, we're talking about this. What is in B? Which B? Which B are we talking about? What is in B is this one. This is what is in B, this one. This is what we have in what? In B, this one. This is your B, set B. So if we are saying it's not in B, what is it that we are referring? We are talking about this whole part outside of B, outside of B, outside of B. So what is the relationship, guys, from our understanding to say what is in B, this one, and what is not B? What does it tell you, guys, in your understanding? This one, what is in B and what is not in B? What is it that it tells you? By having this, as you can see, guys, they're sharing two things here. We've got two things that we are having in this whole diagram. This part of B and this part that we are saying it's not B. In your probability, when you occupy a sample space, what is it that you understand? When the sample space is being occupied, that is where we talk of a probability being equal to 1. When it has occupied everything, to say this part that we are saying, it is representing B on probability. And this part that we are saying, it's not B in terms of probability. When they are taken together, as you can see, this shaded part here and this out, it is giving us the whole sample space. And the whole sample space is equal to what? It is equal to 1. If you understand it that way. But guys, I talked about this, guys. You need to understand just the basic. You need to go, you don't need to go all through all this. Understanding the complement concept of each and every set. Each and every set, if you are given the probability of A, if you add to the probability of what is not in A, which is the complement of A, you must get a 1 from the complement concept. So meaning say from this, I can calculate any one that I want. So it was, in this case, we want this one, not B. All right, I just hope, guys, you understand this. So 3.11, so the probability of not B, which is B complement. Here we are simply talking of what? B complement is equal to 1 minus the probability of what is in B. You take this one to the other side, it becomes what? A 1. This is simply means what? B complement. What is not in B? B complement. The complement of B. So that was going to be 1 minus the probability of what is in B as it is here, 0.5. So that was going to also give us a 0.5. Probability of A or B from the understanding of this is our set notation in terms of our probability, the basic law, as we just talk about, the Venn diagram concept. This is the first thing that you're supposed to understand. Remember, I said the probability of A or B. Since there's an intersection there, it is not equal to the probability of A plus the probability of B like this. You end there. No, this is wrong. But we must subtract the intersection. The probability of A plus the probability of B. We have to remove the intersection. Why removing the intersection? Because the intersection is those terms which are occurring both A and B at the same time. So there's a repetition of terms there. So that must be subtracted. That is why we have to subtract this, A and B. Remember, A and B shows those terms that are found in both. So those ones, they're just a repetition. We have been presented in one of the sets. So it must be removed. So probability of A is there. We are given 0.4. That of B, we are given 0.5 minus that of A and B, we are given, which is 0.25. So that was going to give us the probability of A or B. Simplifying this whole part was going to give us 0.65 as a decimal. You can have it as a fraction. It was going to be 13/20. Same as this one, you can have it also as a fraction because you're not given an instruction there. So that is the probability of A or B. Then this one, the probability not A and B. I discussed about this question and we had a lot of views and like confusions from that type of a question. Probability not A and B. When you read, you do not read the way that you want you as an individual. No, read according to the way that you are given. If they want to say not A or B, the way that, not A and B, like the way that many of us were asking in the previous exam questions that we had on probability. They could have asked this way. There are two ways. Please understand this because these questions are going to be asked and they want you to be confused here. 3.13 like this. I want first to have the presentation. The probability not A, it's not A, this one is on its own. It's on its own, guys. Probability not A. And B, it's a set on its own. This simply means we're talking about the probability not A, remember, means what? The complement of A. What is not in A? The complement of A. And B like this. B, it's a set. There's no complement there on B. They're not same. So you guys, you wanted this question to be given this way. The probability, this is what they do. Then they'll write not. Then they open a bracket like this. Then they write A and B like this. This is the type of question that you wanted. Look at the presentation here. Market is affecting these two, meaning to say it's not part of A and B together. This is where we are talking about A intersection B, all of it like this with a complement, all of it. The bracket, not this one. This one is for A, not A. It's not affecting B. B is on its own. They can give you same question as probability of A and not B, like this. That is, A is on its own. The not there is not in B. It is not affecting A. It is not in B. This is B complement. So be careful. Be very, very, very careful. So how do you find this probability now? Remember, when you're dealing with the Venn diagrams, presentation of Venn diagrams, I'm going to have a class actually to talk about this, because that is the easier part that you can have this. When you are presenting your Venn diagram, let's say we're talking of, not this one. Let's ignore this one. Let's say we're talking about not A and B. This is the easier parts that you can understand me. Not A and B. What does it mean? It simply means A intersection B complement. What is not part of the complement? It's easier for you to demonstrate this in terms of the Venn diagram. You just say, okay, this is my A, this is my B. I have A and B like this. This is my sample space. What is not in A and B? Remember, this is A and B, this one. This is the intersection here of A and B. But we are saying what is not part of this, outside of that. What is outside of the intersection? What is outside? This is exactly the part that we want, this one. Which is outside. This is your guy, this one. This one is your A and B, this one, A intersection B. So what is outside there is the one that we are saying it's not A and B. It's not A and B. That is A intersection B complement. If they had asked it this way, you're going to take these elements outside, meaning to say you're going to work with what? The probability of what? A and B. Then you subtract it from 1. This one, you just subtract it from 1. So it's going to be 1. The probability of this will be equal to the probability of 1 minus, or 1 minus the probability of A and B. A and B, which is A intersection B. You remove that from 1. Remember, the whole of the sample space in terms of probability adds up to 1, like I said. If it was that way, you asked about this, guys. That's why I'm explaining about this part here to say it is not what you were expecting here. No. This one, according to our question, A complement and B, what does it mean? A complement mean intersection B. Let's remove the end when it is like this and put intersection. A complement intersection B. In your understanding, which set is equivalent to this one, which is easier for us to understand? Which set represents this? What is not in A? Okay, guys, no problem. This part here, it represents, in terms of sets, it is called, or it is equivalent to the probability of B only in a simplified manner. You must be very careful there. It is equal to the what? B only. Okay, let's say I do not know these laws direct. What can I do? Let's go back to our diagram. We said in terms of the diagram, it was supposed to be like this. You okay? You understand me, guys? Because last time we had this question, still challenges. So if it is still having challenges after these, guys, please make sure that you do revise your probability as much as you can. So there's another way, the way that I explained last time, and I hope by explaining this time is going to be fine. I was saying When you are given this, first locate that A complement. Understand about it first. What does it mean? A complement, what does it mean? This is set A, this one. Set A means this. This is your set A. What is A, this one? So A complement, it's something that is outside of A, like this. This is A complement. What is outside, guys? Out of A, it must be outside, like this. Outside of what? Of A. This is your A complement. Let it be outside of A. This is where you know that your A complement is. But if we say and, what does and mean? Let's go back. Intersection. What does intersection mean? We are talking about a condition where both occurs. Where both occurs. What is not in A, this part that we indicated, these elements that we have indicated, where are we seeing these elements also found in B? That is the question. Where are we seeing what is not in A found also in B? Because it's supposed to be both. So for you to see that, indicate the set B so that you can properly see this. If you indicate B, this is set B. This. When you talk about set B, we are talking about this one. We are not talking about B only. We're talking about B like this. Like this. This is your B. So if you are to shade B, you're going to do it like this. You're going to do it like this. This is the whole of this part is your B. But we need a condition where these elements that, remember the elements that we are shading before these ones, they are not in what? They are not in A. So where do we see these elements being common to those ones which are found in what? In B. So we are focusing now at B only here. Here. This is the piece that is remaining, this one. Where the elements that are not in A, they are also found in what? They are also found in B. These are the ones. These ones, they are not found in A. Remember the first part that we shaded. They are not found in A. But these ones that we are shading right now in red, these ones, they are in what? In B. They are found in B. They're found in B. So they will meet it. This one is not going to work. The intersection is not going to be taken. Remember the intersection here. It's not in A. It was removed when we said A complement. A complement means A is not there. If we take this part of A is not there, this one. Anything that has to do with this A, anything is not supposed to be here when we use and. Because we are saying it's not found in A. Guys, where are these elements, this one? How do you present this element, this one? Here, that I'm shading right now, this one. I just want you to see what I'm saying, this part that I'm shading right now. What is the name of this region? It is A and B. A and B. But we are saying A is not needed. Because the moment you say not A, and we see that A is there, because the moment you say A and B, you have included A that we do not want. They are saying not A. A is not supposed to be there. So we do not want something like this. A is not supposed to be there. So the moment we take that, we are wrong. We are wrong. So we are not supposed to take that region. So that is our answer. That is the content of our question. So you're simply going to take these elements here that I'm indicating here in red, which represents what? They represent here. Which one? What do they represent, all these? They represent B only. If you were to represent it on a diagram, guys, you can say this is equivalent to what? B only. Remember, we've got set B. Then we've got B only, the remaining part, which is not part of A. So that is what I was explaining on the first part, that this is equivalent to what? Probability of B only. So if you understood it earlier, you are not going to go through this. But it is also important for you to understand it's part of your syllabus, this one, understanding Venn diagrams. So if this is probability of B only, where are we going to have it? How do you find the probability of B only, this part here? B only. How do you find its probability, this region? How are we going to find the probability of this region? What is it that we need? What can we do? This is the region that we're talking about. All right. What can we do, guys? We want the probability of this part. Okay. If I have the whole of B, this one, the whole of this B here, if I have it, because I'm given that, the probability of B is what? 0.5. And this one on the intersection is given A and B. It's 0.25 here. A and B, 0.25. How can I find this part that is remaining? I simply have to subtract B minus that one which is on the intersection. So this here was simply going to be the probability. What is in B? Remember when you are presenting on the Venn diagram, when you're given terms and you are representing in terms of X, let's say this is X and you're given this is A, this is B, and B has got 20. How do you find B only? You're subtracting 20 minus X. Also in terms of probability, it's like that. Probability of what is in B, 0.5, minus the probability of what is A and B there on the intersection. It was going to give us what? What is remaining in B only what is in B, which is what? 0.25. So that was our question, the probability of not A and B on another part. Read to understand and also understand your diagrams, your Venn diagrams. They can help you. If you understand this in short, then it is good to have that. 3.2. You were given in a school of 70 grade 10 learners. How many are we having? 70 of them. 32 learners take economics, which is E. 32. 43, they take mathematics, which is M. Then 15 learners take neither of these two subjects, meaning to say they do not take these two subjects. They do not, these ones, they do not take this one. The two subjects. So if these people, they do not take these two subjects, where are they? If these people that we are given, these are the ones that are outside of the sets. If you're to present your sets, those are the terms that are outside, if you still remember your set concept. So you're not worried about that. Let the number of learners who take both subjects be X. 3.1, show that X is 20. And on 3.22, they want you to draw the Venn diagram to illustrate the above information. So if you took it that way, you're going to have a confusion to say, so they do not need a Venn diagram on this first part. No, they're not saying that. You can use that illustration in terms of X. 3.22 is another question. So these sets, they have an intersection because we have got those learners who take both subjects. So if we have this in terms of our Venn diagram, I'm going to present that way so that it can be easier for us to understand here. We're supposed to have something like this in terms of X, whatever that we have there. So sample space, and we've got learners that are taking mathematics, and we've got those ones. Okay, the first one, it was economics. So let's start with the way that we are given. First one, it was economics. Then the other one, it was mathematics. So we are given that X both. Like I said, when you indicate and try by all means to start with those ones that are at the intersection, both. So they are X there on the intersection. So this is your X. So considering what you're given there, we're given that 32 learners, they take economics. 32. This is the set of economics, this one. This is economics. This one. That is where we have the 32. But as you can see inside that, there is also X here. Inside of those 32 that we are given in economics here, there is also X, which are on both. How do you get rid of these X? We subtract 32 minus X. Same thing with the mathematics here. We are told that how many learners they take mathematics? 43. They take mathematics. So many say this will be 43 minus X, because the whole of this is 43. But to find those ones we are taking maths only, you must remove X. And remember, I told there are those 15 that take neither. They do not take any of these two subjects. There are 15, so you write them outside. So this was going to, if you know, like your understanding of the Venn diagram being used to that, you can just have an equation. You don't need to present it like this. But it is wise that you do that, because this exam, guys, do not know where you can have a mistake. So from this, we can find the value of X, because remember I asked you to show, calculate it and show us that it's what? It's 20. If there are 70 grade 10 learners, meaning to say the sample space is carrying 70 learners. So this being added together must add up to 70. Okay, that is the 32 minus X plus the X plus the 43 minus X plus the 15 that is outside is supposed to give us a total of 72. Thus, we have formed an equation where we can solve for this X. So simply add the numbers, guys. 32 plus 43 plus 15. You add the numbers together. That was going to give us a 90 there. Minus X plus X, these two, they cancel. You remain with minus X, which is equal to 70. So minus X is equal to what? If we take the 90 to the side, it is going to give us a negative there. It was a positive. So 70 minus 90, that's minus 20. You can divide by -1, both sides. So we obtain the value of X, which is what? A positive 20. So that was the value of X. As we can see, that is what they want you to show. And after that, they want you to draw the Venn diagram to illustrate this above information. So on drawing the Venn diagram, we are now putting exact values that are needed. This was just an illustration that is helping us to calculate. But on 3.22, you're supposed to have exactly the values that are within each and every set, from the economics, mathematics, and our sample space. Remember, there are 15 which are not affected. These ones, they're outside of the set, outside of the two. Then on the intersection, this is the X that we just calculated. Both X, we have it, which is 20. So you're going to put the 20. So it's going to affect here 43 minus X, because that is for mathematics only. So if you put your X here, which is 20, it means we've got 43 minus 20. That is the idea of the question. And that was going to give us what? 23. Same thing on economics only there. 32 minus X. Your X is what? Is 20. So they want you to fill in now. So that was going to give us a 12. So this is economics only, mathematics only, both economics and mathematics. Not part of any of these two. These ones, they take neither. They do not participate in these subjects. So that was your Venn diagram. 3.22, you're done. On 3.23, they want you to use the diagram now, or any information that you have, to determine the probability of a learner taking A, economics and mathematics. You haven't, or are we not given that? This is the interest. Remember, X represents both. So you have it X there. Economics and, this is the part of the intersection and. All right, so you can just remove this part here because need our calculations which are necessary. Remember, the whole of this sample space is out of what? 70. There are 70 learners. So on this question of 3.23, part A, we need the probability. We are saying what? Economics and mathematics. So this is economics and mathematics. How many do we? And. This is the intersection. How many people are there? These are not probabilities, no. These are numbers. The previous case, you were given probabilities, all right? Sorry, on this part here. They gave you as probability of this. So when you are presenting your it's probabilities. Still, they can be presented on a Venn diagram, knowing that the probability of the sample space, everything, adds up to 1. But there we are talking about the numbers. We have to calculate it from the numbers. So probability is what? What is in this set of what? E and M. They are 20. Out of what? The total. How many students do we have in the sample space? How many learners? 70. Just like that. So on your calculator, that was going to give you a 2/7. You can have it as a fraction. You can have it as a decimal. So if you round it as a decimal to 2 decimal places we are given, it was going to be 0.29. You can have it as a percentage, the way that you want. That's it. On another question, B, a probability that at least is going to take at least one of the 2 subjects. At least one of the 2. What does it mean? This one. Probability of taking at least here, one of the 2. One of the 2 subjects. What does it mean? The probability that we take at least 1. This is where we are talking about those people that if you enter, let's say, a class, you ask them, are you doing economics? That person can answer yes. Are you doing mathematics? That person can answer yes. Any person that will answer that question, whether that person is doing 2, because at least it means starting from 1 going up. But if we go in this same class, in this same group of people, I want you to understand this. You have the same group of people. You ask these ones here, are you taking economics? What do you expect to have as an answer? Definitely a no. Are you taking mathematics? That's definitely a no. Worse, if you ask, are you taking both of the 2 subjects? That's a definite no. So we do not want these ones. These ones, we do not want them. They are not part of economics. They are not part of mathematics. So we can simply remove them from what? From the 70 to have those ones that are at least. So we can simply subtract 70 minus what? Those ones who do not take any of, which is the 15. That was going to give us 55. Or from our diagram again, because these ones, they say they're doing these subjects. So we can simply add them because we do not want this. So meaning to say we want this. These are the ones that we want. These ones, they do economics only. These ones, they do economics and mathematics. These ones, they do mathematics only. They are part of at least one of the two subjects. So these are the ones that we want. So let's add them. 12 plus 20 plus 23. We are going to have the same answer as what we had, the 55. Out of how many learners? Out of 70. So it was going to be 55 out of 70. And you can reduce this to 11 over 14 on your calculator, or as a decimal to 2 decimal place. It was going to be 0.79, something like that. Probability can also be a percentage. So take note this. Where are you having your answer there? All right, I think it was direct, this one. Then other one, that the probability of taking take note, exactly one subject. Exactly one subject. Which of these ones on our Venn diagram, they take exactly one? Whenever you have this type of a question where we deal with exactly one, what does it mean? Okay, this was part C. Probability of choosing exactly one. So from them there, they even wrote this in upper caps. Exactly one subject. Simply means those are the ones that are taking mathematics only. That is only one subject that is doing this person. What about these ones? They're also part of our answer. Economics. Only. Exactly one subject. So we are talking about two probabilities. Probability of M only plus probability of E only. So you can simply add, since they are on the same diagram, we can just add them. 12 plus 23. Out of what? The same number of people they are affecting out of 70. So that was going to give us 35 out of 70 as a decimal, which is same as 1 over 2 or 0.5. That is how it can be like. That is how it can be like. Probability. Understand the question. Small presentation that you're given, try by all means. You see, that's a lot of marks, 21. Anyways, let's say 2.4. What are they trying to say here? The probability that a mathematics learner is also, take note, is also a physical sciences learner is 79%. Determine the number of learners that take physical sciences. They're saying these two, they go hand in hand at a 79% rate, to say, in terms of probability. Those ones that are in mathematics and those ones that are doing the physical sciences to be the same, it's of 79%. So how can we know the physical sciences? We can calculate those ones that are doing maths, because we are saying if the learner is doing maths, is also doing what? Physical sciences at this percentage. So for us to have the physical sciences, guys, we can simply use that percentage to calculate the students that are doing physical sciences, because they are also doing mathematics at this percentage. So we are going to use 79%. But it's 79% of what? Of what? Are we given anything about physicals to know? The only part that we are given is of mathematics on this diagram, on this information. These are mathematics. So how many learners do we have for mathematics now? 43 tech mathematics. We are not talking of mathematics only here. We're talking about anyone that is doing mathematics. As long you're doing mathematics, that is the question there. So there are 43 learners that you're going to multiply to, that you are given. So 79% of this was going to give us 33,97. These are students. Can we say 33,97 learners? Can we say 33,97? It's impossible. We're talking about number of people. We are not measuring, we are counting numbers. So you round off to the nearest next digit, which is going to be what? 34. So it's going to approximate to 34 learners in this group of physical sciences, according to the percentage that you are given. So for 21 marks, like I said, this is a lot. Understand also instructions, like the way that you're given the question, let it make sense. Try to understand how the question is being given. So moving on to question number 4, we were given that at a school athletics day, a stopwatch was used to find the time it took a group of athletes to run 200-meter event. Okay. So the results were recorded in a frequency table below. So these are the results with the frequency table, class interval. This is grouped information, grouped data. They're given 20 to 30 and so on. The frequency, which is the number of athletes. And they're saying on 4.1, how many athletes ran the 200-meter event? These are the athletes, the number of athletes, the total frequency is the one they want. All of them. How many? So they want you to find the total. Simply going to add 6 plus 16 plus 21 plus 8. That is the total of the athletes, which is 51. So that was your total frequency there. 4.2, calculate the estimated mean as we are to relate to this grouped information. How do you calculate the mean? From the information that we have, since this is grouped information, okay, that's 4.2. So the mean can be calculated using this X bar like that. Okay, so which simply is equal to, that is the sum that you're going to have, the summation, which is the sum of frequency times the class centers or the class midpoints. So this is the sum of the product of frequency and class centers over what? The sum of the frequency, which is the total frequency. So this simply means sum of. Sum of. So we have frequency, and this X is your class midpoint or class center. Or our class center. This is grouped information, remember. So this was going to give us the mean. So you need in each and every class to have the class centers. Remember how to determine the class center or the class midpoint. The class midpoint, you simply add what you have on the lower class boundary plus what we have on the upper class boundary. You divide that by 2. You have the class midpoint. So for the first class, the frequency is 6. Remember, frequency times class midpoint. So 6 times class center. You add these two values. Divide by what? By 2. 2 plus 30, divide by 2. Or you can even see the number that is between. That is what we say. The number that is found between 20 and 30, the number that is in the middle of 20 and 30. So even if you know it without calculation, you say this is 25. Between 20 and 30, the number there is what? 25. Or you can simply add 20 plus 30 over 2. That was going to be 25. So this is what you're going to do throughout. Like I said, you add. Sum of, you add. The next one is 16, the frequency. What is the class center? From 30 to 40. You do the same thing, 30 plus 40, you divide by 2. So that was going to give us a 35. That's our class midpoint there. Plus, we move on to the next one. The frequency there is 21. So it's going to be 21 times the corresponding class midpoint or class center between 40 and 50. Do the same thing. 40 plus 50, you divide by 2. You're going to get 45 there. You do the same thing on the last one. The frequency is what? 8. 50 to 60, you do the same thing. 50 plus 60 divided by 2. So that's the frequency, remember, which is 8. Then from 50 to 60, class center or class midpoint is going to be 55. So this is the sum of frequency times class midpoint over what? The sum of frequencies, of which you calculated here, because these were the frequencies that you're adding here. So already the sum, we calculated this. If you are not asked this, then you're going to add them 6 plus 16 plus this plus this. But there, they asked you on the first question. So you just take the answer there, which is 51. You calculated this. So that was going to give us the mean. Multiply everything as we have it on top like this whole part that we obtained. Combine everything on your calculator. That was going to give you 2095 over what? Over 51. And as a decimal, you're going to get 41,078 and so on and so on, which is 41,08 to 2 decimal places. So this is the idea of your mean. An estimated mean. Class center is needed. Class midpoint. Frequency is also needed. The product, you multiply them together, adding each and every part. That is the sum of. Then on 4.3, what is the model class interval? This is the class that is the highest frequency. So in terms of our frequencies here, where do we have the highest frequency? On 21. So we need the class that correspond in terms of the interval. Which interval carries the highest frequency? Which interval has the highest frequency? So is interval of what? 40 to 50. So that is, you write as it is given there, 40 less or equal to x less 50 as it is given there. All right. 4.3. Identify in which class interval. Identify. That is the question there. In which class interval the 30th percentile lies? In which interval are we going to have the 30th percentile? Remember from the concept of the median, those percentiles, this and that. The first thing is to locate what is called position, the position of that term, 4.4. All right, let's see. Just like you're calculating the median, remember if you're calculating the median, half of the distribution, that is for the mean, for the median. Whenever you're to calculate your median, half of the distribution, because you said for the grouped data, if you are to present this maybe on a cumulative frequency curve, whatever that you have, if it is grouped data, it's just half of the distribution. Ungrouped, where you are given those digits 1, 1, 1, 1, 1, 1, you can use half of what? Half of n plus 1. That is where you use, is supposed to be strictly used as it is. But here you can ignore that. So the same concept as you are calculating half of the distribution, you talk of the quartiles, 3/4 of the distribution. It is the same thing when they say the 30th percentile. percentile, these are percentages. We are now referring to the percentages. So the first thing is positioning of that, like I said. So the 30th positioning, it means what? 30 over 100 in terms of percentage times of the distribution. What is our distribution? Our distribution is 51. There's no need for us to add anyone. If it is grouped data like this, you can just use it as it is. Even if you add one, I'm not saying it's wrong, because other textbooks, they might be giving you those formulas like that, but there's no need. So this is the 30th percent of the distribution. We are locating the position. Where is it going to be? So that was going to give you 50,3 at position. Like this is a position where it is going to be found. At this value, we are going to find it. So how are we going to use that now to determine that exact value now? The interval, the class interval. How are we going to have our interval now? So for the interval now, because we got that it's at 15,3. And as we are going, dealing with the percentile, just consider your cumulative frequency. Remember, it's like this. You are going up. This is 0, 1, 2, 3, 4. It's going up 0, 1, 2, 3, 4, 5, up to 100. So the 30 is showing that we are going up. So we are going to count going up. Remember, these numbers are going 6, going up this way. They are increasing as they are increasing, not the other way. No, we only take in one direction. So you have to locate where this value is going to lie, this one. Where is it going to be found? In which class are we going to have this value occurring? Okay, let's start with the first one. The first value there is 6. Guys, 6 is less than 15. We are not having this value. So it cannot be the first class. That is how you figure out. You add 6 plus 16 because you are increasing, like I was saying, values are increasing. So if you add 6 plus 16, what are you going to have? You are going to obtain a total of 22. 22. Guys, this is the 22 that we have now. Comparing it with 15,3 that we see here, this one, we can see that the 15,3 is inside of, it is, when you are counting 6, this one, because you added 16, so you're counting 6, 7, 8, 9, 10. 15,3 is within this 22, this one, because values are now at what? At 22. So it's within those numbers. 20, 21, 22. The 15 is there because we're now at 22. It is accommodated in this value. That is what I'm trying to say. So if it is accommodated in this value, at which interval also is it accumulated? The 22, where did it happen, the 22? It happened when we added 16. So we are under this interval. We are under this interval. That is our interval that you're working with, this one. We are under this interval, 30 to 40. So if 22 occurred under this interval, it means also 15,3 occurs under the same interval of 30, less or equal to x less than 40, like that, the way that you're given. This is the interval where we have the 30th position. They can ask you for the median, half of the distribution. They can even ask you in terms of the quartile. Where do we have 3/4? Where do we have the upper quartile? You just calculate 3/4 of what? Of the distribution first. 3/4 of 51. You find the position, then you count where is it going to lie. You take the class that is corresponding to that number that has occurred, like what we saw. It is occurring in 22, and 22 occurred under this class. So guys, please do read your questions clearly and also do as many questions as you can. 4.5. Represent now the data on a histogram using the attached diagram sheet. On a histogram, this information that we have here. So you're going to take your values, guys. All right. This is as they are. I say that in our presentation or our level, we are going to be given same class intervals. If you check, the width of the class is the same, 20 to 30. There's a difference of what? 30 minus 20. There's a difference of 10. A difference of 10. A difference of 10. A difference of 10. 60 minus 50. So you just use your class intervals as they are versus these frequencies. So you're given on your diagram sheet, this is what you had so that you can be together. So this is part of our diagram sheet. We have our histogram. They presented, is them who gave us. So you have to follow the way they presented from 0, 20, and so on. So you must consider this as a class. To say the first class is from where? 20 to what? 20 to 30. 20 to 30 versus the frequency which is given of 6. 20 to 30. From 20 here to 30. But as it is going up, it must reach a frequency of what? Of 6. As you can see, that is what you gave, a frequency of 6. So I'm just going to try present this, guys, going up from 20 here, going up until we get to 6 here. From 30 going up until we get to 6. Then we can join our bar like that. So 20 to 30 versus what? 6. It must correspond to 6. 20 to 30. Another one that you're given, 30 to 40 versus what? 16. It must go up to 16. From 30 to 40. It's a continuation from 30 to 40. But it must go up to 16, up to 16. So you can just continue with this bar up to 16 here, up to 16. We do the same thing at 40 up to 16. So you guys are supposed to do something that is neat than the one that I'm having here. You're supposed to do something which is presented better. 30 to 40 corresponding with what? 16. The bar is supposed to go to 16. You move on. 30 to what? 30 to 50 versus 21. 21. Are we having 21 direct there? We do not have 21. This is 20, 22. So you can just make an assumption that 21 is in between what? Is in between there. It is in between. So let's say this way, we have in between 20 and what? And 22. In between 20 and 22. So this is between 40 and 50. So you're going to take this bar going up to what? To 21. Like I said, you just approximate in between like this. You do the same thing at 50 going up. Just approximate maybe somewhere there a little bit. Then you can join these two like this one. You now have this at what? At 21. Approximately in between 20 and what? 20 and 22. We are not given a number there which is 21. So you approximate in between. That's from 40 to 50. From 50 to 60, it is 8. 50 to 60 here. Versus what? 8. 8 is there, we can see it. So it's going to be at 8 here. So we need this one. 60 going up to 8. This is your 8. Then you can join here because it's already under a continuous line. So this is it. We have your histogram. You can even shade this histogram if you want. Just leave it like that. That's your histogram. So they wanted you to present this way. You were given. So that is it, guys. For how many marks? For 3 marks. As you can see, guys, it was fine. Just information is already there. Just to draw those bars, make sure you present your information properly. So that was it. Question number 4, 11 marks. Let's check question 5. And on question number 5, you were given the following life science marks for a test out of 50. So the test was out of 50. Were recorded from 15 grade 10 learners. There are how many? 15 learners. This is the total number of learners, the total learners that we are given. There are 15 grade 10 at a certain high school. 5.1. Write down the median. They are not saying calculate, they are saying write it down. It's an answer. You just have to take it from your information. Remember, median is the middle term when these numbers are arranged in order of size. They are already in order of size. So we can just cancel which one is in the middle. We can cancel this one. We cancel this. 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 We cancel this one. We cancel this one. As we cancel this, we cancel this. We cancel this. We cancel this. As we cancel this, we cancel this one. So you're going to see that there is a term that is remaining not cancelled in the middle, which is 24. So meaning to say our median was going to be equivalent to what? 24. That's why they are saying write down is something that you do not need a calculation. But let's say you need a calculation. How are you going to do it? You are going to determine first what is referred to as the median position first. Remember, from the same way that we had, only difference that this was grouped. The information, the data that we have here is grouped. This one is not grouped. You're just given randomly. This is ungrouped information. Ungrouped. It's not grouped. This just given one on its own. This one, it's ungrouped. So on ungrouped, now you have to use half of the distribution plus 1, half of n plus 1. You must use plus 1 this time. There you were just using half of n, half of the distribution. There you must use half of n plus 1 to locate the position first. Where is it to be located? Where n is the total number of terms, total number of learners, 15 plus 1. So it's going to be half of what? 15 plus 1 is 16. And half of that 16 is 8. So you're talking about the 8th position. The 8th value is where our median is. So you have to count 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. The 8th value in that position is your median. So you can see that it corresponds to what? 24. Same answer that we got with the issue of just cancelling this and this and this until you get the middle term, which is the median. So there are so many ways, guys, that you can answer this to have your median. On 5.2, determine 5.21, the mean of the data. The mean. That's 5.21. As we do understand the mean for ungrouped information, it can be calculated using what this time? Sum of all terms, which are x terms. So the mean being given as x is going to be equal to what? Sum of all x terms over the number of terms. Sum over total. This is ungrouped. You add this 10 plus 13 plus this plus this. So just use your calculator, add everything up to the last digit here, up to the last one. You add all these. You are going to get 387. Using your calculator properly, add everything, add these up to the last one over the number of terms. How many learners do we have? There are 15 learners all in all here. There are 15. So you divide by 15. That was going to give us 25,8 as your what? As your mean. This is different from what we had when we calculated the mean here. This is grouped information. So the mean here is supposed to be from the sum of frequency times the x that we talk about there is the midpoint, this one. It is of the midpoint or placent over what? Sum of the frequency. This one, it is the same as what we refer as n, the sum of the frequency, like how many learners are there. So these ones, they are being taken one. So you just say number of learners, number of x values. Just like that. So there are differences, grouped and ungrouped. You need to know your formulas and how to calculate those values. 5.2 to the range, as we do understand whether you're talking about temperature range, this, wherever there is range, maximum minus what? Minimum value. So that is the idea there. So what is the maximum value? That is our range. What is our maximum? Minus our minimum. Our maximum value is this from minimum going up, last value. So that is the idea. This is the minimum. This is the maximum. These values, they are already in order of size, as you can see. So the maximum value obtained was 49. The minimum was what? Was 10. So the difference is there, is the range. So that was going to give us 39. And we do move on to another part, the interquartile range. As we do understand, in order for you to obtain this 5.23, to obtain the interquartile range, you are going to need the upper quartile and also the lower quartile. We do understand that. Upper quartile minus the lower quartile. And these quartiles, they are obtained the same way as we had the median. So that's, we're going to need these quartiles. How do you determine Q1? First, we need its position. Lower quartile, it's a quarter of what? The distribution, n plus 1. This is ungrouped, so you have to use what? N plus 1. Please take note, n plus 1. Any number of what? X value, the data that you're given, which is 15, as we saw before. N is what? 15. So it was going to be a quarter of 15 plus 1, which is 16 here, and a quarter of 16 is 4. The fourth position is where Q1 is to be found. As the values are increasing, going up, the fourth position, so you're going to count 1, 2, 3, 4, which is what? 17. So Q1 is 17. That's where we have our Q1. The value that is there, answer corresponding to the fourth position. This is the same thing that you're going to do even for the upper quartile. Because it is what? 3/4 of the distribution. So we need its position first. 3/4 of n plus 1, you do the same thing. 3/4 of 15 plus 1, which is 3/4 of 16. And 3/4 of 16 was going to give us 12. So we need the 12th position, the 12th value in terms of positioning. What is on the 12th value? So you have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's count properly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is this one, which is at what? at 29. That is where we have the upper quartile there. So the first thing is the positioning. Then we have to determine the Q3. So the Q3 is there, 29. We have it. So the question was, we need the interquartile range. We take the corresponding values, not the position. No, we need the exact value representing Q3 as our upper quartile. That's 29 minus Q1, which is 17. So the difference there was going to give us what? 12. That's our interquartile range. Just like that. So the first thing, position. Position first. Then talk of what? The values that are corresponding. Then on 5.3, they want you to draw a box and whisker diagram to represent the data above. Draw a box and whisker. We can see that, remember, our box and whisker, it is controlled or taken from the 5-number summary, where we talk of the minimum value, the lower quartile, the median value, which is a 24. Remember, we've got our median value there, which we stated before, 24 here, which is Q2, or you can just write median. So we said minimum, lower quartile, the median, the upper quartile, and the maximum value. This is what builds up our 5-number summary, which builds or gives us the box and whisker plot. So with that, we were just going to present, guys. I'm just going to put a sketch, 5.3. So like I said, I'm just going to present this in form of a sketch, but you're supposed to do exact thing. All right, so let's just have it even here, 5.3. So remember, you need the part of the whisker here where we need the minimum value. Then we go to the box and also the end of the whisker here. So you put a certain scale, which is important. But when you are not given, like, you can just have it as a sketch, like to say this value here, this is our minimum value, remember. This is our minimum value. It corresponds to what? To 10. This is the part of the lower quartile, Q1. It corresponds to what? 17. Q2 is the median. Let's say it is somewhere here. Just present Q2, your median. It corresponds to what? 24. You can even write a number there, 24. Q3, which is our upper quartile, it corresponds to what? 29. The maximum value at the end there, it corresponds to what? To 49. So you just have it as a proper diagram, but it's not that smart. You're not given a scale like, present like, you just have a sketch. So these are corresponding values, which you can just even put, like, if you're having, let's say, a number line like that, I'm just saying these values, they correspond to this. So instead, if you do not want confusion, you can even write these numbers here. If you do not want it to have it like this. Guys, when they say draw, you can just put them here. 10. This is 17. This is 24. This is 29. And this is 49. Just like that. You're done. You have your marks. Draw properly. Presentations are supposed to be clearly done. The pass mark for the life sciences test was 30%. How many learners passed? We have a 30%, guys. You have passed. So the question is, how can someone have 30%? This test is out of 50. So when you say you've got 30%, which mark can we consider as a pass mark before we talk of the learners who pass? Because these are not percentages, these ones. Guys, be careful. They gave you here as a percentage. These are not percentages. These are marks. The following life sciences marks for a test the test was out of 50. So for you to know the mark first, let's talk about the pass mark first. What is the pass mark? They are saying you must have what? 30%. 30%. So the pass mark is simply going to be 30% of what? Of 50. So 30% of 50 is what? That is the question. 30% of 50 is 50. So meaning to say, from 15, you are considered as you have passed the test. Because if you get F, guys, let's go back to our mathematics. Let's say you got a 15 like this one. The test is out of 50. You're going to do like this. 15, how do you calculate percentage? 15, this is your mark that you got. Out of what? The test was out of what? The test was out of 50. You convert to a percentage, so you multiply by what? By 100%. If you do this, guys, you are going to get exactly 30% on your count. 30%, which is the one that they are talking about here. 30%. So you see that someone who has 15 is the one that has got a pass mark, which is corresponding to 30. So these were percentages that, but in terms of the marks, the person is having what? 15. So guys, if 15 is considered this one as a pass mark, if 15 is considered as a pass mark, therefore, how many learners passed? We just have to count. This is the 15 going up here. These are the learners who passed. All these ones, their marks are greater than 15 going up, from that 15 going up. So you have to count 1, 2, 3. How many learners? So you can simply, you see, okay, there are 2 learners here who failed according to this. There are 2 learners who failed, who got 10 and 13. So it was easier for you guys to simply remove these 2 from what? From 15. Remember, there are 15 grade 10 learners. So 15 minus 2 is what? Is 13. So meaning to say 13 learners passed the test. That is the condition. 13 learners passed the test. Or you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 18. You can see them. It's a table. It's a table. Do whatever that you want with it. Understand it. This is what they're trying to say. So the first thing was to know what is the pass mark, because we are given this as marks, not as a percentages. So sometimes they will give you these as percentages, then they state it that way, that to say 30%. You're just going to go straight to that. If they, maybe in terms of mark, they can even say here, they can even specify the pass mark was, and they give that pass mark not as a percentage, but they give you exactly the pass mark was 15. How many learners passed? You can, there you are, they have already given you that the pass mark is 15. So you say, okay, this is the pass mark. So all these they did what? They passed. But yet they wanted to confuse you by giving you a percentage, not a mark, not the exact mark, like 15 out of this or 30 out of this, like out of 50, out of the 50 marks, because this was marked out of 50. So you see, guys, they want to confuse you. You have to be careful when presenting your answers. This is exam. You are being tested. It's a test. You are being tested. So know your story. Question number 6. Given f of x is 2 sine x plus 1 and gx is tan of x, where x is supposed to be taken from 0 to 270. This is the interval that we are given there. And the question on 6.11 was write down A, the period of G. This is the graph of a tan. We know this period, guys. The graph of a tan, it has a period of what? 180 degrees. From 0 to 270. It's just, if you're talking of a normal graph of a sine and a cos, those are the ones that have got a period of 360. But this one for a tan, it's 180. Please know that. Then the range of f, this is your f. Remember the range it's a condition where you are referring to the y values as the graph was being drawn. We do not know because we're going to draw this. So it was easier if you take it from the graph because you're going to draw it. Let's say this question here, guys, you don't understand it. And they're saying draw these graphs like this. Ignore it. All right? Ignore it. Leave it like that. Answer it after you've drawn the graphs properly. Okay, I'm going to explain that one. But for now, how can we answer the range? Like, given this? The range we're simply talking about when the graph is being drawn, definitely it's going to be something there. Maximum and mean, we need to know in terms of the y values, what is the minimum value and what is the maximum value? That is the range. So for this one, it was going to need you to adjust from the normal graph that we are used to. Remember, the normal graph of a sine is like this. Now they need you to understand your graph. That's why I was saying, if you do not know this way, please leave it. I'll explain on after drawing. Remember, this is the normal graph of a sine x. Y is equal to a sine x. This is the normal graph, which has a maximum value at 1 and a minimum value at -1. So it is now you guys who is working with the graph. You are asking yourself to say, what happened to that original graph? Transformation. Now there's a transformed graph. So what happened if this graph was transformed this way? We can also do the same thing because we are talking about what? The range being of minimum, focusing with what? With the minimum, and also focusing with what? Maximum value. So we just do the same thing. This is your minimum value, this one, on an original graph of a sine. But this is not what happened. What happened to sine? They're saying it's 2 sine x. So it means it's 2 times anything that sine x was going to give you. And sine x at the minimum value, we're talking about the minimum value here on the adjusted graph. Sine x, its minimum value was supposed to be what? Was supposed to be -1 originally. So you multiply to that minimum value. What happened after that to this graph of sine when it was multiplied by 2? 1 was added to the resultant. So whatever that you have here, you must add a 1. So 2 times -1 is what? -2 plus 1, which is going to give us what? -1. This is where we are. This is what you're having. So according to the value of the minimum of the original graph of a sine, which is at -1, and this one, which has been transformed this way, we can see that there is no adjustment there. There is no adjustment, all right? So no problem. There is no effect like or on this one. It remains the same. Guys, it is just by coincidence that you are seeing these values being the same. Never use what sine originally gives you and you just say, there are no changes there. I'm just going to take them as they are. No, let's go to the maximum. So the y value, the minimum is -1. What about the maximum value? We do the same thing, considering the maximum value. We work from there, from the maximum. Our graph has been transformed this way. It's what? 2 times anything sine x gives you. Anything that sine x gives you at the maximum value, what is it that you're given originally? It was supposed to be a 1. And we can see that also out of that, after doing everything, 1 was added to the new function. So you do the same thing. So 2 times 1, that is 2 plus 1, which is what? Which is 3. On this new graph that we are talking about, guys, the maximum value is going to be found at 3. You are not going to see it at any other value, but it is going to be at what? At 3. That's your range. So range you can even write as the y values. Y is what? We need the -1. We also need the 3. So it's greater than or equal to -1. The same y that we are talking about, less or equal to 3. It's a range, the Y values, output values. No problem. We'll see this when answering the next question, like I said. The question now was on question 6.12. On the same set of axes provided on the diagram sheet, sketch the graphs of F and G. Clearly indicate all intercepts with the axis as well as turning points and end points of the graphs. That is where we talk of the turning points there. That is where we're going to talk of what? The minimum and maximum value. That one is going to answer this question of the range. If you do not understand that way that I explained, you will leave a space when you are in exam. Do the second one, then you come back and answer this. Let's see. Let's start with the first graph. 2 sine x plus 1, which is the graph of f. This is what you're given according to your graph. This is what they gave you. And we're talking about the graph of f of x, which is equivalent. We say this is 2 sine x plus 1. So according to what you're given, you can see they gave you, these are the x values, which are the angles, like 0 degrees, 45 degrees, 90 degrees. This is what it means. So you can simply use a calculator because you can see from 0 to 315. But according to our interval, we need from what? Let's go back here. According to us, we need from 0 to 270. 315 is just given like here, but us, we need to end here at 270. So how can we draw this? We can simply substitute our values, guys. Use a table. If you're used to do that one, okay, you can just substitute your values there. All right, having your table. So remember when dealing with the graph of a sine, what was your step, the step that you're using when dealing with the graph of a sine? You're working with a step of what? 90 degrees, 90 degrees, 90 degrees. You can do that. 90, 180. Those are the major points when dealing with the graph of what? Of a sine. The step. The 45 that we are seeing there is best when you're drawing the graph of a tan. When I'm talking about the step, I'm talking about the separation of angles. The separation of angles. How are you going to separate your angles from one to another? The graph of a sine, whenever you see this sine and cos, sine and cos, it is best to be separated at what? 90 degrees. The graph of a tan is the one which is best to be worked at what? 45 degrees. So here they combine because you're drawing two graphs at the same time. So do not work with those 45 degrees for, okay, this is what I'm trying to say. Let's go to our calculator. I want you to see something. Right, I'm just going to put my calculator back to the normal mode so that you can understand. If we check here, this is 2. You want to use 45 degrees and see. There is a 45 degrees there. 2 sine, this is 2 sine x. In place of x, you put 45 degrees like this. Then you add a 1. Okay, look. 1 plus square root of 2 as a decimal, 2,41. Where can you locate that in this step? It's difficult. But if you use those angles, the step of 90 degrees, if you separate by that concept that I was using, 90 degrees, you see, you get an exact value. You move on from 90 to 180 degrees. You see, you get exact value as long as you separate by 90. So it's best. I'm not saying to use the 45 is wrong. It is best for you to separate your graph that way. It is best this way. So since we have a sine, it means we're going to use what? 90-degree interval. So the first one, 0 degrees, 90. Remember, you're separating by 90. So it's 0 plus 90, which is 90. 90 plus 90, that is 180. 180 plus, guys, you are adding 180 plus 90, which is going to be 270 degrees. 270 plus 90 is 360. 360, we cannot have it because of what? We are told here the interval from 0 to 270. We are now limited there. So we cannot use 360. Also, we cannot use this 315. It's just given on our diagram, but Just, we're not going to use this. So we end up with what? 270 according to the interval that we are given of the x value is greater than or equal to 0, less than or equal to 270 degrees. That means our x is being taken from 0 to 270 degrees. So you substitute these values now on your calculator to find the exact corresponding y values which you need on that graph. So let's start at 0, that's 2. Sine, you put a 0 there, plus 1. Okay, so if I first close the bracket, then you add a 1. So as you can see, we're going to get a 1. You move on to 90 degrees, you do the same thing. So this is what you're going to do, guys, on each and every part. Move on to this one. This is 90 degrees, you're going to get a 3. You move on to another one, 180 degrees. You just substitute there, put 180 degrees. This was going to be 1. You move on to 270 degrees. You put 270 degrees. This was going to give us -1. These are the values that we are getting from the y values after substituting this x. So you just need to mark your points. Let's start with this one first. 0 versus 1. That's 0 versus 1. 90 versus 3. When this is 90, we're supposed to go to 3, positive 3. 180 degrees versus what? -1. Versus positive 1. 180 versus positive 1, according to our graph. This is 1. Then 270 degrees versus what here? 270 degrees versus -1. This is what we have. 270 versus -1. This is -1 down here. -1, -2. So you're going to mark 270 versus -1. So this is it, guys. You have ended. These are the points that you have. You do understand the shape of a graph of a sine was supposed to be like this. So you maintain the same shape, but using this. So this is it from this point. Gonna get to that point here going down. So just to go back to this point. All right, at this point, at 215, there's nothing there. It's just for a turn. Do not concentrate with that one. So it goes like this until this point. So it was supposed to have a curve, then it goes up like that. But as we're not focused, because we are going up to, we are ending at 270 degrees. That is where we are ending. That is where we are ending. So this is what we're going to have as the graph of what? Of a sine from our f. F of x is equal to. So let's figure out about that previous question, which I said we could have answered this question here after drawing, because this is the graph of f. We just drew the graph of f. Remember range, minimum to maximum. So you can even tell it from the graph. This is our graph. What is the minimum value of this function? You can see this is the minimum corresponding to what? -1. Maximum on top there corresponding to what? To 3. So as you can see, we've got the same answers from -1 to 3. So if you did not understand the previous calculations which I used on the range, you can use the graph like I just did. All right, let's move on to the graph of a tan x from 0 to 270. We need on the same system of axes here. But as I was saying, the graph of a tan, it is best that we use 45 degrees. Separate these by what? 45 degrees. So meaning to say, you're going to just have our tan of x. So here I'm just going to show you a simple thing. So you have got your x values and your y values. So that's 0 separated by 45. So this is the one that you're using as it is. So it was going to be 0, 45 degrees, 90 degrees, 135 degrees, 180 degrees, 225 degrees, and 270 degrees. Remember, this is the end point. Use your calculator to simplify the tan of 0, get your answers, and so on and so on. The tan of 0 there, which is what? All right, let's see. That's a 0. Okay. Tan 45, use your calculator, substitute that. Place of the angle, you put a 45. It was going to give us a 1. Okay, let's see what was going to happen at 90 degrees now. At 90 degrees, do not be surprised. We have got a 90 degrees there. Met error. This does not exist. This does not exist mathematically. It's infinite. We do not have values corresponding to that. We do not have values corresponding to that. That is what it means. There are no values. That is where you indicate what is referred as those asymptotes. That is where the asymptotes play a role. So it simply means at 90 degrees there is no value that can ever occur. There is no value that can ever occur on the graph of a tan. It's an asymptote. At 135, you're going to substitute on your calculator. You're going to get -1. At 180, you're going to get a 0. At 225, you're going to get a 1. At 270 degrees, the same thing that happened at 90 degrees was going to happen. Thus, we also have an asymptote. So at 270 degrees, it shows us there is no value that can ever happen there as long we are to talk of the graph of a tan. And also knowing your shape. Remember the graph of a tan, guys, it will be having those shapes that are weird. From 0, this is the point, 0 versus 0, 45 versus 1. So how do you join the point? Because it is not supposed to meet here at 90 degrees. There's nothing. So you indicate as if your graph is going to approach this, but it will not reach this value like this. It goes back to 1. It cannot reach this. It's an asymptote. We saw that there are no values there. You do the same thing. 130 versus -1. This was the point. 180 versus 0. 225 versus 1. These were the points. But the graph cannot reach 270. The graph cannot reach 90 degrees. So you're going to take your graph from this side. Remember, it cannot reach this line. It cannot meet with that line. So you just join somewhere like this. All right, this is not a straight line, guys. This is not a straight line. Do not even confuse to a straight line. Then it goes up. As it is going up, it will be tending as if it wants to meet with this line, but it will never meet with this line. Same thing that happened this side. It will never meet at what? At 90 degrees and at 270 degrees. Those are asymptotes. So that's the graph of G. This is the graph of G. You can write your G here. You can write your G here. That was the idea of the question. So with the table, you can see that. Unless if you know this graph, but with the table, it's easier. If you understand this table, you can even do it on your calculator straight away. Just using your calculator. Each and every value that you use, you mark it on the graph. Each and every value, you mark it on the graph. It can be easier that way. Now they want you to use the same graph to determine the value or values of x, where gx is greater than or equal to 0. The graph of gx. When the graph of gx is to be said it's greater than, or maybe it's the graph of f of x, whatever graph that you are given, when we are just saying this graph is greater than or equal to graph of gx is greater than or equal to 0. This is where we have x, which is this is where we have our x-axis, where the y values will be equal to 0. When we talk of f, gx, these are y values. We are simply saying the y values, they are supposed to be greater than or equal to 0 on the graph of what? On the graph of G. The y values must be greater than. If y is equal to 0 in the x-axis, So where do we have y being greater than or equal to 0? Thus, we are talking about values which are above the x-axis, because there y is 0. So anything that will be found above, on top of this x-axis, on top, it must be a region which is on top of the x-axis. As long as it's on top of the x-axis, that region that we are representing is greater than or equal to 0. Starting from the x-axis, going up. If it was less than, we are looking about these ones down. Where is the graph affected? Down the x-axis. So where is G affected? Above. That is the question. Above the x-axis. Where do we have our G affected? Okay. If we check, this is the graph of G. We've got the first piece here. This piece that we are seeing here, as you can see, guys, it's above the x-axis. Look where it is. It is on top of the x-axis. So how do we write our answers there? Because we're talking about the x values. So how do we write our answer? From 0. This is the interval. Are we going to meet 90 degrees? No. We are moving, yes, exactly from 0. But look, this is G. G cannot meet with 90 degrees. Like I said, those are asymptotes. So we can say x is greater than or equal to 0. But x cannot be equal to 90 degrees. It is less than 90. It cannot be equal to 90. So x here is supposed to be less than 90 degrees. There is no equal to here. There is no equal to, because of that asymptote. Within this interval that I have just written here, from this 0 up to a region that is less than that, the graph is on top of the x-axis. Y, any value of y, if you take any here, any y value that you want, it's positive. That is what we are trying to say. Any y value there is greater than, it's positive. So we answer it in terms of x to say from which x values. All right, if we check here the other piece, because this is still G. Remember, we're talking about G of x. Is indeed this graph of G? It is graph of G also. Is there a part where we have this graph above the x-axis, above y zero? Yes. If we check this side, it is below this one. So you cannot take this. But starting from 180 here, we can see that starting from 180 like this, going up, the graph is above, is in this region that I shaded. It's above of the x-axis from 180. So it's another interval again to be taken from 180 degrees. X can also be taken greater than or equal to 180 degrees. Up to where? Are we going to meet with 270 degrees? Are we going to reach that? No. Remember, that's an asymptote. There is nothing there. So x cannot be equal to 270, but it can only be what? Less than that. At 270, it can never give us a value. So we're not supposed to include that even in our presentation. So that's our interval, where G is positive, as you can see here. G is positive. Above of what? The x on top. If they wanted a condition, let's say they wanted a condition. Here we're done. This is your answers. These are your answers there. So let's say they wanted a condition where, let's say they said gx is less than or equal to 0. Meaning to say it's now below the x-axis. You're talking about this region. This is where we have, was the first part according to our interval. For it to be below, it was supposed to be at this other side of the graph, of which we are not talking about this. So the first one, it's actually out, the first piece of G. This one, I talk about the piece of G. So we move on to the second piece of G, this one. Where is it below x-axis? You can see within this region here, it was below. From where? Are we going to be talking of 90 degrees? No. X cannot be equal to 90. So X is supposed to be greater than 90 degrees. From that, values that are greater than 90 degrees up to where? Up to 180 degrees, up to a condition where X is less than or equal to. Equal means it's also involved. It's also involved. This is where GX is less than. So they can ask it like that. It's not like they're going to repeat this one. They can ask it this way. So understand your graphs. Know the concept. Know your question. How are they given? All right, let's answer 6.2. They are saying a handyman attempts to reach the roof of a wall with a ladder 15 meters in length. All right, so this is what we see here. This is the ladder that was being put in place. 15 meters, attempting to reach what? The roof. Attempting to reach the roof of a wall. So unfortunately, the ladder is too short. And a new ladder will be required. Suppose that the length of the ladder needed to reach the top has to be double the distance from the what? From the foot of the ladder to the wall. It has to double the distance here from the foot to the ladder. This is the distance from the foot to the ladder like this. So they are going to call it X. Let's say it's called X. So they're saying the ladder that we are going to have, which is our new ladder, this one. This is the new ladder that is needed to meet what? To reach the roof. They are saying the length of that ladder, for it to reach the top there, it must be double this. It must be double. It must be 2 times. So that's where we are given this as what? As 2x. That's what they're trying to say. It has to double. Please read this. Do not just answer. Read what does it mean? The angle between his current ladder, the one that he had, the one that is now having, and the ground will need to be equal to the angle between the 2 ladders. So this current, the one that you had, current, because remember, this is we need to have it. So they're saying these angles are equal. These are ladders. Remember, this is the first ladder, this one. This is the first ladder which failed to reach the roof. I mean, you say this is the roof, this one. This is the top now. Because this one managed to reach what? The roof. So this one, it was not reaching the roof. It was reaching part of the wall. Then we need the second ladder now. This second ladder is the one that managed to reach the roof. All right? So you need to understand this. The above situation is dissipated. Dissipated on in this diagram below. Calculate the value of theta from there. 6.1. Calculate the value of theta. You had limited information to determine theta. We can only find theta if there are 2 sides. Let's say, because we are on a right angle triangle. Let's say I'm given this side and I'm given this side. Or maybe I'm given this side and this side. Whatever, as long as there are 2 sides, we can think of the trigonometrical ratios. But in this case, the given sides were not given in terms of to say this is 2, this is 3, this is 2 meters, this is 3 meters. No. The 5 cannot be used with x because these are there is one unknown given. So it's impossible for us to use this. But if you consider the bigger one, the bigger, this one. When you consider the outer part of the triangle, this one. If you consider the outer, this one, the outer part. There is what? There is 2x. There are sides that are given that you can consider there. If you consider that, there is 2x. It's an unknown value, that one. But remember, there's x. And this one is also having x. So if you combine the angle between where x is and this 2x, if you combine the angle, this one, what will be the angle? Remember, this is theta, this is theta. So theta plus theta was going to give us what? 1 plus 1, that's what? 2 theta. So you're going to write this angle as 2 theta instead. You have combined this triangle. You're not using this one because you can't use this unknown. There's the one that is given and the other one is unknown. But if you use these two unknown, I want you to see what was going to happen. Remember, you need theta. Let's have our 6.21. So this is what you're going to have. According to this, it's a right angle triangle. Remember, it was supposed to be like this, but we ignored this part and we took the whole of it as it is. So according to this, our theta, this is our adjacent. And according to this 90, opposite to 90 degrees, the one that faces the 90 degrees is your hypotenuse. There's only one ratio from our SOHCAHTOA concept, which has this adjacent hypotenuse at the same time. It's only one part, the cos, adjacent over hypotenuse, the cosine of theta, but this time is no longer theta, it's 2 theta. The angle inside is 2 theta. So the cosine of 2 theta is equal to adjacent. What is our adjacent? Adjacent over the hypotenuse. All right, so on this one, it has actually affected everything, but let's see how we can have our question answered. Just gonna try and have it on this one because I don't know, guys, you know, these things, softwares, just have to also be patient with this. So this is our 2 theta, like I was saying. We've got our 2 theta, and this was our x and 2x. So as I was saying, this is going to be the cos, because we've got adjacent and the hypotenuse. So you're going to use that cos as the angle is being combined. 2 theta is equal to what? What is your adjacent? That is x. So if you use this, you're going to see that this is x and this is also 2x. So you'd be surprised, like, so how am I going to obtain an angle because I have x and x? Do not worry, guys. These are all unknown, so they can cancel each other and you remain with 1 over 2. That was the tricky part. So if cos 2 theta is equal to this 1 over 2 or a 0,5, how do you obtain the angle? Remember, I said the angle from our trigonometry is equal to what? When given a cos like this, it is going to be arc cos of what you're given of the fraction or the decimal. Arc cos, this one, which is shift cos on your calculator. So guys, as you can see, because of this effect of the board, I cannot now use that calculator, but this is what you're going to do. Arc cos, shift cos, 1 over 2 on your calculator. So you get 60 degrees. So in your level or on your level, just use the angle that you get there. You're not going to work with any other angles that we're going to have, that part we're going to talk about in grade, when considering grade 11. So you take that angle as it is, 60 degrees. So you have the angle now. So this is the idea. But you're writing here as what? 2 theta, because that's our angle. So 2 theta is equal to what? Arc cos of that, which is this one. Arc cos of this. It was going to give you 60 degrees. So divide by 2, you now obtain the value of what? Theta. Because this was 2 theta. We combine theta plus theta to give us 2 theta. So what is theta as a single angle? You're going to get 30 degrees if you divide this. So meaning to say we've got our theta, guys. This is 30 degrees. This is also 30 degrees, meaning to say if you add 30 plus 30, 60, or 30 times 2, it was going to be the whole of this. It was going to be 60 degrees. But we just need theta. Exact theta is what? Is 30. This is one they're also giving you guys. If theta is 30 degrees, determine what length of the ladder should B, to get the handyman to the roof. Remember, I was talking about the length of the new ladder as we had to be what? To be 2x. This is where we have, this is the length of the new ladder, which is 2x. So we cannot use this triangle, this one, even though we know that this is 60 degrees. We cannot calculate the value of x with this ratio because of what? We do not have any other side to use. But if we get to this concept now and understand this here, that there is a side which we are given here of 5 meters, we can now take this and make it part of our diagram into involvement using that triangle. Using this triangle, I want you to see something. This is 90 degrees. From here to here is what? It's 5. So we're going to take that 5 meters. The angle that is affecting 5 here, 5 meters, the angle that is affecting is the theta here inside this one. This is the angle that is affecting 5, which is what? 30 degrees. Not the 60. No. We're talking about here inside this triangle. You use the one that is inside that triangle. That angle is 30 degrees. You were given that this is x. This triangle can help us to calculate the value of what? The value of x. This triangle is going to help us to calculate the value of x because you can see we have a side that is given and one unknown, our trigonometrical ratios, where we have adjacent and hypotenuse from our soccer toy. So it's cos. So cos of the angle is equal to the adjacent, which is x, over the hypotenuse, which is 5. That is what we have. So you're going to calculate the value of x. This is the same as over 1. You're going to cross multiply. 1 times x is x, which is equal to 5 cos of 30 degrees on your calculator to 2 decimal places. Like I said, guys, I cannot use the calculator now because of this thing that just happened. So it was going to give us something like 4,33. This is x, the distance that we have here in what? In meters. This one. If it is 4,33 meters, how is it going to help us now to find the length of the ladder, this one, the new ladder, which we are told that the relationship between the distance from the foot of the ladder, from the foot to the ladder, of the wall to the ladder, is or can be related to the length of the new ladder, because the length of the new ladder is 2x, 2 times this. So if x is 4,333, like what we have there. Therefore, the length of the ladder can be calculated because the length of the ladder is given as what? As 2x. Length of the new ladder. Okay, the length of the new ladder can be calculated because we are given that it's 2x. So if it is 2x and we calculated x, we have it. We calculated it. 4,33. That was going to give us the value of x. I mean, the value of 2x, which is the length of the new ladder. And that was going to be 8,66 in meters. That is the length that we have. So this is it, guys. As you can see, we just have to be very, very careful. Then try by all means to work as much questions as we can. And as you can see, guys, these softwares also, they do affect us on our side. So that is why sometimes we try to be rushing, guys, so that we do not get disturbed like what just happened. But we just hope all be the best as you are revising towards your exams. This is the busiest. Like I said, when I was explaining about the topics about this term, this is the busiest term. Revise as much as you can, as you have to consider from what you had in your term 1 and so on and so on and so on. So consider this, revise with it in this term 4 as we are entering our term 4. Let's use this, revise as much questions as you can. We are going to be using, I just work with your request. If you want me, I can present those ones for November so that it can help us. The ones which were written November 2023. We revise those ones together so that it can help as much as we can in our revisions till we meet again.